lesson 53. Just to double check, can you guys see my lesson 53 notes? Okay, thank you. So I'm going to kind of be jumping back and forth between this screen and then also my unit circle screen. So again, everything that I write down will be here for your reference at any point. But again, feel free to write down anything for yourself so that you have it. So starting off with kind of setting the scene here, and this is a little bit what we were doing yesterday, use your unit circle to find all the possible values of theta in radians from 0 to 2 pi. So if I asked you to solve number 1, where is the sine of theta equal to positive 1/2? You would have to look at this equation and you would have to say a couple of things. You would have to say, okay, I know that a sine is a y value. I know that this is a positive y value. If I want there to be a positive y value equal to 1/2, I would have to look at my circle. I would be looking in quadrants 1 and quadrants 2, and I would be looking specifically for ordered pairs that had y values of positive 1/2. So that would be here, and that would be here, which means my answer to this problem in radians would be pi over 6 and 5 pi over 6. So again, equals a positive 1/2. You'd have to know that a y is a sine. You'd have to know that sines are positive in quadrant 1 and 2, and you'd have to correctly be able to identify those answers in radians. So let's go ahead and write that down. So theta would be equal to, those answers were pi over 6 and 5 pi over 6. That's an old skill that you should know from earlier in the chapter. So again, if you're having any trouble with that, you should either ask or just be sure to review. Let's go ahead and take a look at the second one. So the cosine of theta is equal to negative root 3 over 2. The background knowledge that you would need to answer this question, so you would have to know that cosines are x values. You would have to know that because it's a negative x values occur in quadrants 2 and 3. So if you were looking again at your unit circle, you would have to be looking in quadrants 2 and 3. You would have to specifically be looking for ordered pairs that had a negative root 3 over 2 in the x's. That would be here and here, which means your answers would be 5 pi over 6 and 7 pi over 6. Then for the tangent, so the tangent being equal to positive 1, you would have to know that a tangent is a y value over an x value. You would have to know that in order for the tangent to be positive, that could either occur if you had a positive divided by a positive, or if you had a negative divided by a negative. So that means you're going to be looking in either quadrant 1 or quadrant 3. Further, the only way that the tangent can be a 1 is if the sine and the cosine are equal. So the x and the y have to be the same. That's the only way that they could divide to be just a 1. So again, as you look at your unit circle here, you'd be looking at quadrants 1 and quadrants 3. You'd be looking for ordered pairs that have the same cosine and sine. So that would be here at root 2 over 2, root 2 over 2, and also here at negative root 2 over 2, negative root 2 over 2, which means your answers would be pi over 4 and 5 pi over 4. And that's what we're going to go ahead and add into our answer here. So theta would equal pi over 4 and 5 pi over 4. So you need to make sure that you understand those basic pieces before we go ahead now and make it a little bit more complicated. So before I do that, any questions at all on 1, 2, or 3?
I have a question about the tangent.
Yeah.
Could you go over why you chose like 2 pi over 2 and whatever? I'm not really understanding like you said that the sine and cosine have to be equal.
Right.
Could you just explain that like a little further, please?
Sure. So if a ratio of a tangent is a y over an x, and that turns out to be a 1, the only way that that can happen is if you divide something by itself. Like if you divided 5 by 5, you would get a 1. If you divided a half by a half, you would get a 1. So you can only choose a value on the circle where the X and the Y are the same. So the only ordered pairs that have an X and Y that are the same is here and here. So if you were to divide the square root of 2 divided by this, if you were to do square root of 2 over 2 divided by the square root of 2 over 2, because the top and the bottom are exactly the same, that's why they would cancel out to be just 1.
Okay, that makes more sense. Thank you.
Sure. So again, any questions up until this point? Okay, so the information that I've written so far, that only pertains to question 1. So I'm going to go ahead and get rid of that. And now I'm going to point out a couple of other things. So going back to what they were just asking me about the tangent, there's a couple of, if you printed out this specific copy, there's some information here that will always be true. So here at 0, the tangent is equal to 0. Here at 30, the tangent is root 3 over 3. Here, the tangent is 1. Radical 3 and undefined. So they're telling you what those tangents are, which means you can then use them all the time, because remember, those don't change. So feel free to highlight those and then use them as a reference. Additionally, here in quadrant 1, they've reminded you of the all students take calculus, which basically tells you what is positive and what is negative. So there in quadrant 1, they're telling you that everything is positive. Here in quadrant 2, they're telling you that the sine and the cosecant are the only positive things and everything else is negative. In quadrant 3, it's only the tangent and the cotangent that are positive. And in quadrant 4, it's only the cosine and the secant. Remember, if you think of it as the all students take calculus, that's just kind of a shortcut for you to try to remember. But at the end of the day, if you can't remember, you're going to go ahead and use the blue to help you. Any questions on that? You could even go around the circle and write in all the tangents for every single ordered pair. Just remember that if you're changing each quadrant, like even though these tangents would be the same for every member of the family, they could be positive or negative depending on the quadrant. So it might not be a bad idea at some point to go around and write all those in, but just make sure you're using the correct positivity and negativity. So going back to the actual lesson here, it asks you now in the next slot, we're now going to use our calculators to solve. Is it going to give us the same answers, yes or no? So if we were going to go ahead and try to solve number 1 using a calculator, the way that you get rid of a sign is by taking an inverse sign. So theta would be equal to the inverse sign of positive 1/2. If you were trying to solve number 2, you would get that theta would be equal to the inverse cosine of negative radical 3 over 2. And if you were to do number 3, you would get that theta would be equal to the inverse tangent of 1. So if you have your calculators, you should take them out. This is still in radians, so you technically should be in radian mode, although the conclusion would be the same if we were in degree mode. But if you have your calculator handy and you do the inverse sine of 1/2 in radians, it is going to give you an answer, but it's only going to give you one answer. It's going to give you a decimal answer, but that answer is going to be equivalent to pi over 6. Whereas in number 2, if you do the inverse cosine, remember that's second cosine, make sure it brings up the little -1 of negative radical 3 over 2. That's going to tell you that theta is equal to 5 pi over 6. Again, it would give you the decimal equivalent. And then if you do number 3, the inverse tangent of 1, it's going to tell you that theta equals pi over 4. So if you take a look at those answers compared to the answers we got in the previous problem, the truth is you do get the answers, but you only get half of them. So I'm running out of room a little bit, so I'm just going to write it over here on the side. So basically for number 2, so the calculator only gives half the answers. You would have to use the unit circle and reference angles to find the others. And FYI, that's actually what we were doing on the previous slide when we found those answers. Without really realizing what you were doing, you were actually using reference angles. That's how you were able to tell me it was 5 pi over 6 and 7 pi over 6. So it's not like it was an extra step, just so you know that's what you were doing. But basically, your calculator, while it will give you some of the answers, it will not give you all of them. And so you have to kind of be smarter than your calculator. And there's also a reason for that. So the reason for that brings us to something called the inverse sign. And really, there is the reason why this is a thing is because there are calculator domain restrictions. So the reason why you only got half the answers was because your calculator is restricted. So how is it restricted? Well, I'm about to tell you. So we've been using the word inverse for a while now, but we have to kind of drill down a little more in terms of what does that actually mean. So to start you off with a little bit of a throwback back to even chapter 1, in order for something to have an inverse, it has to be 1-to-1, which means it has to pass the horizontal line test. Remember that the vertical line test is what tells you if something is a function. The horizontal line test tells you if something has an inverse. Because of the fact that the sine wave goes on and on forever and repeats, if you were to try to do the horizontal line test, you would fail quite often because you would hit the graph more than once for any given y value. So the sine wave fails the horizontal line test. So what you have to do instead is you have to restrict the domain, which means you're only ever going to use a specific portion of the sine wave. We're always going to choose the same portion. And that portion is going to be the portion of the sine wave between negative pi over 2 and positive pi over 2. So again, you're not going to have to memorize any of this because you're going to have this information in front of you, but you just have to make sure that you know what you're looking at. So again, to summarize, because the sine wave goes on forever, it does not pass the horizontal line test, which means it doesn't have an inverse. In order to guarantee that it has an inverse, you can only take a small portion, and that portion is always going to be from negative pi over 2 to pi over 2. Technically, you could take other pieces, but that's the piece that we're always going to choose. Why do we choose that piece? Well, there are 3 reasons. Reason number 1, in that piece, the graph is increasing, which we like. Reason number 2, even though you're only taking a small slice, it still incorporates all of the y values that the sign provides. It goes all the way from negative 1 to positive 1, which means it technically encompasses all the sign values. And most importantly, the reason why we choose that specific interval is because in that blue interval, you will pass the horizontal line test, which means that an inverse exists. So I don't know if you know enough to know whether you have questions or not yet, but anyone? Something else to point out over here, these are going to be your negative y values, and these are going to be your positive y values. And again, that's just something to keep in mind in terms of whether your answers are going to be positive or negative. So we're always going to choose this interval, negative pi over 2 to pi over 2. And again, these are the 3 reasons why. So now if we kind of formalize that a little bit, if you always take the interval negative pi over 2 to pi over 2, that is what's going to be called the inverse sign. And there are now going to be 2 ways for us to say that. One is going to be sine to the negative 1, which is what we're used to. And the other is going to be something called the arc sign. That is a popular way of writing the notation in calculus. Remember that to the negative 1 means inverse, which is what this is. The fact that they're saying the arc sign, they're just specifically talking about the angle or arc whose sign is x. So again, don't make it harder than it is. These 2 things are just 2 different ways to say the inverse sign. But for some reason, the arc sign seems to be a little bit more popular. So please just make sure that going forward, you know that they're synonymous. The most important thing that comes as a result of everything we've done so far, if we're going to go ahead and define the inverse sine function, again, we're going to call it most times the arc sign, because of the fact that we are restricting the values of the domain and the range of the sine function. That means that those values are going to swap when it comes to the inverse sine function. So that means that we are going to have a domain and range of -1 to 1 and -π/2 to π/2. Again, if you go back to this original sine wave here, because we're restricting the domain to be -π/2 to π/2, that means that the range is -1 to 1. Remember, the whole point of inverses is that everything swaps. So when you're talking about the domain, that's now going to be -1 to 1, and the range is going to be -π/2 to π/2. Again, this is what I was talking about when I was saying, I don't know how hard it is, but it's technical and detailed and nuanced. So you're going to get plenty of chances to see what kinds of questions I'm going to ask you. And again, I'm happy to take your questions at any time, although you might not know enough to ask any yet. So what does that mean? Why do we care? What's up with this domain and range stuff? Well, here's why we care. So if a problem starts as an inverse, and again, so it has to start as an inverse for all this stuff to be valid. If you just happen to be using an inverse at some point, you might not necessarily have to worry about it as much. But if a problem starts as an inverse, you can only give answers in the restricted domain and range. So write that down, and then you're going to see it in action in just a minute. Give you a second just to kind of catch up and see if you can digest. And again, if you are able to ask a question yet, lay it on me, although you might need a little more time till you actually see what the problems look like. And so before we actually even get into the problems, the next most important piece is the graphs. So in order to graph an inverse, you're going to do the same thing that you always did. Remember back in chapter 1, if you were going to graph an inverse, you would interchange the x and the y. That is still going to be what you're going to do here. You just have to do it a little bit more carefully. So if you printed this out, the graphs are actually on the back. So let me just go ahead and jump to those for a minute. So here you have the sine, and then you have the inverse sine, which again is called the arc sine. You have the cosine, and then you have what's called the arc cosine, and then you have the tangent and what's called the arc tangent. Just so you know, there are inverse secants and arc cotangents and arc cosecants, but we're not going to do those. So you only have to be responsible for the big three and their arc sines. Couple of things to point out here. So in every instance, notice that the domain and the range has swapped. That's the whole point of being inverses, is that every point has to swap, including the domain and the range. For the sine wave, that's what we did on the previous side. We only take the sine wave from -π/2 to π/2. And again, part of the reason why we do that is because here I'm going to get all the negative y values, where here I'm going to get all the positive y values. That is always the rule for sine. The rule for cosine is that you're always going to restrict it to be between 0 and pi. If you're always going to restrict it to be between 0 and pi, then here is where your positive x's are, and here is where your negative x's are. If you're talking about the tangent, you're only going to restrict it from -π/2 to π/2. And again, in terms of the graph, here are where your positive y/x's are, and here is where your negative y/x's are. And again, the stuff that's highlighted in yellow, those are the rules. Whoever did this lots of years ago decided that those were the domains that we were going to pick for the arc, sine, cosine, and tangent. So those are the ones that we're going to stick with. So questions so far? Okay, then further, so the domain of the sine and the cosine, arc sine and arc cosine, is from -1 to 1. What that actually means is that you can only find an arc sine and arc cosine from -1 to 1. That is what that domain restriction means. You can only calculate problems for an arc sine or an arc cosine between -1 and 1. Little bit different for the arc tangent. Look at the arc tangent. So because even though you're restricting the domain of the tangent, the range is all real numbers because it goes all the way up and all the way down. So it turns out that when you change that domain and range, the arc tangent winds up having a domain of -infinity to infinity. So you can have the arc tangent. So you can find arc tangent of any x, whereas you could only do sine and cosine for -1 to 1. Again, I know still kind of a lot of background information. We still haven't even yet gotten to the questions, but it's all important, I promise. And again, just as a reminder, there are technically arc, cosecant, secant, and cotangent, but you're not responsible for those. Finally, the very last thing that's going to help us on our journey to solving these problems is going back to this reference. And I'm going to now give myself some information in terms of where I'm going to look for my answers. So in quadrant 1, that is where you're going to look for arc sines, and in quadrant 2, between 0 and it has to, so the arc sine again is, oh, sorry, no, hold on, sorry. Okay, so from here, again, the first thing that you're going to want to do is, because of the fact that you're going from -π/2 to π/2, you want to take your values in the fourth quadrant and you want to now convert them to values that are between -π/2 and π/2, which means from this point forward, you're going to refer to 11π/6 as -π/6 and -π/4 and -π/3 and -π/2. Remember, those are coterminal angles, but you're going to have to have those values in order for you to be in the appropriate domain. So again, from this point forward, instead of giving an answer, or at least when it comes to arc sines or arc cosines, you're going to give your answers in terms of -π/6, -π/4, -π/3, and -π/2. Again, that's because you can only be from -π/2 to π/2. Then in terms of where you're going to look for your answers, so for the arc sine answers are only going to come from quadrant 1 or quadrant 4. Same thing for the arc tangent. And then for the arc cosine, it's going to be quadrant 1 and quadrant 2. And again, I'll point that out a little bit more in depth in just a minute. But if you're looking for arc sine, arc tan, or arc cosine, they all could have answers in the first quadrant. Sine and tangent can also have them in the fourth quadrant, where arc cosine can either have it in quadrant 1 or 2.
So are these based off of the restricted ranges?
Yes.
Okay.
So again, give you another second in case you're writing any of this down. But again, you're going to be able to refer back to it if you need to. So it'll be here in the class notebook if you need it. But yes, those restrictions are because of the restricted ranges. So if we go back to our notes here, we're finally ready to actually answer some questions. And we're going to go ahead and start here. So using the inverse sign, find the exact value. So when it comes to these problems, two things we have to keep in mind. The domain of these problems has to be from -1 to 1. And the range of these problems has to be from -π/2 to π/2. Those are the same rules we wrote for the graphs, the same rules in the definition. I'm just writing them again so that we are certain. Here's the first thing that tells me. Because of the fact that the domain is -1 to 1, if I check all my problems, -1/2, √3/2, -1, and 2, I can automatically see that number 3 is not going to work because 2 is not inside of the domain. So just so you know, this one is a no solution. And the reason is X is not in the domain. All the other answers do have a solution. You just now have to find it, and you have to find it in the appropriate interval. So for these 3 questions, I can only look for answers between -π/2 and π/2. So the arc sign of -1/2. The arc sign of -1/2 means the following. Look at your unit circle. You're looking in quadrant 1 or quadrant 4, because you have to be from -π/2 to π/2, and you're looking for any place that there's a sign value of -1/2. Hopefully you would notice that that location is here, but you're not allowed to say 11π/6. Instead, you have to say -π/6, because you have to make sure you're in the correct domain. So the answer to this problem is -π/6. For the inverse sign of radical 3/2, the inverse sign, and again, either notation you're going to see. So the inverse sign of radical 3/2 means you're going to look at your, you're going to look at your unit circle. You're going to look in quadrants 1 and 2. You're going to look for any place where there is a positive sign of radical 3/2. That location is going to be here, which is π/3. Π/3 is in the correct range, so that's going to be your answer. The arc sign of -1, that means you're going to look from -π/2 to π/2. You're going to choose any value that has a y value of -1. Hopefully you can realize that that's actually down here, but you can't say 3π/2. You have to say -π/2 because of the restriction. So it's mostly just a lot of little technical details that you have to keep in mind in order to get the correct answer. Again, if you have a question thus far, let me hear it. If not, maybe seeing more of them will help.
So just to clarify for myself,
Yep.
solving it is not different. It's just how we write it within the restrictions that changes.
That's a good way of looking at it, yes.
Okay.
So now that we've done the inverse sign, we're going to do the inverse cosine. Just so you know, the inverse cosine has slightly different rules. The domain is -1 to 1, and the range is 0 to π. Again, these rules don't change. So if you write them down now, they're always the same. You just have to know what they are. So to check the domain to start, if you look at all of these values, they are actually all between -1 and 1. So all of them are going to have solutions. And now I just need to find them. Because the range is from 0 to π, that means I'm only going to look in quadrants 1 and 2. So the arc cosine of radical 2/2 means when I look at my sheet, I'm looking for any ordered pair in quadrant 1 or 2 that has an x value of radical 2/2. And hopefully you can see that it's here at π/4. The inverse cosine of -1, again, means that you're looking only at the top half of the circle, and you're looking for a spot where there is an x value of -1. And if you look carefully, that's going to be over here at π. Pi is included in our restriction, so we're allowed to have that as an answer. And then arc cosine of -1/2. So again, you're looking only in quadrant 1 and 2. You're looking for a cosine of -1/2. That's an x value. So that means that your answer has to be 2 pi over 3. Questions? I mean, if it's not your favorite lesson, totally get it. It's really not mine either. Going on to page 2, again, just so you're aware, the stuff that's highlighted, this is all the stuff that is not changing, all the restrictions. So as you go to do your homework over the weekend, use this as a guide, okay? It doesn't change, and you don't have to memorize it because you can literally just look at it. So finally, we're going to go ahead and do problems with the inverse tangent. So when it comes to the inverse tangent, something that I want to point out here, so the domain of the inverse tangent is -infinity to infinity. So that means that I'm going to be able to plug anything I want in, which means that it doesn't matter what these are. They could be anything. But again, for the range, you're only going to be able to get answers from -pi/2 to pi/2, which means you can only look in quadrants 1 and 4. So if you want an arctangent of 0, looking at your unit circle, you can only look in quadrants 1 and 4, or between -pi/2 and pi/2, and you're looking for a tangent of 0. Again, whether you calculate it one at a time or you use these facts that are just given to you, there's my only value there at 0. So that is my answer. The arctangent of, or the inverse tangent, again, same thing, of -1. That means that between -pi/2 and pi/2, you're looking for any values that have a tangent of -1. Remember that the only way you can get a tangent of 1 is if you have the same x and y. In order for it to be -1, you would have to have opposite x's and y's. So it's down here at 7 pi/4, but you can't give an answer of 7 pi/4, so -pi/4 it is. This is what I was saying, that if people are still not entirely familiar with the sines, the cosines, and all that stuff, that just makes this lesson infinitely harder. The arctangent of radical 3/3. So looking at your circle, a tangent of radical 3/3, that happens in the pi/6 family. So because you want it to be positive, that means your answer is here in the first quadrant, which is pi/6. So those are all one type of problem. And then the last couple are a different type of problem, which I actually think you'll like better. But questions up to there? All I can tell you is that when you go to do those problems tonight in the homework, do them exactly as I've done it. Use the unit circle. Use these restrictions. There isn't any work to show. You just have to do the thought process in your head and then be able to tell me what the answers are. So there's quite a few of those for homework tonight. So just make sure you're using the appropriate domain and range. And then the second half of the lesson, or whatever's left here, goes back to triangles, which I actually think you're going to like a little more just because it's a little bit easier. So here in number 11, it's a totally different type of question. Use an inverse trig function to write theta as a function of x. So take a look at this first problem. You have theta, you have 4, and you have x. You're going to think back to your opposite, adjacent, and hypotenuse. Given that angle theta, this is your adjacent, and this is your hypotenuse. Does anybody remember which trig function connects an adjacent and a hypotenuse?
Cosine.
Cosine. So you can say that the cosine of theta is equal to 4/x. Instead of saying that, you want to turn it into an inverse trig function. So you would take the arc cosine of both sides, and you would say that theta is equal to the arc cosine of 4/x. You don't have to put parentheses, but a lot of times we do. So all you're doing is starting off with a regular trig function and then changing it into an inverse trig function. How about for the next one? So if this is your theta, this is your adjacent, and this is your opposite. Anybody can tell me which trig function connects an adjacent and an opposite?
Tangent.
Tangent. So the tangent of theta is equal to x plus 1 over 10. To get rid of a tangent, you're going to take an inverse tangent or an arc tangent of x plus 1 over 10. And again, you don't have to use parentheses, but a lot of times they do. Just so you know, it would be equally correct if you just said inverse, but I would like you to have a little bit of practice with the arc notation, since that does happen a lot. One last set of problems here. So in order to do this last set, you have to remind yourself of composition. Function composition means you're going to work from the inside out. You're going to put the answer to one problem into another problem. If I was going to ask you to do an inverse or a composition of inverse pairs, you would have to actually do it very carefully. What that means is if I was to say, what is the arc cosine of a cosine, or an arc sine of a sine, or a tangent of an arctan, that is where it starts getting even worse than the problems we already did. So just use your calculator for those. We're not going to worry about those. To do any other type of problem, meaning that the two things are not going to match, you're going to use triangles and U substitution. Just so you're aware, this word U substitution, this is a calc term. You use something called U substitution a lot in calc. You've actually used it at some point in your mathematical career. Just as a reminder, back in Algebra 2, it's possible that you were asked to solve a problem like this. And you might have said, let U equal x squared. And then you would have changed the problem to be all U's. So in case you're trying to think, what does U substitution means? It basically means that you've decided the problem is too hard the way that it looks, and you decided that you're going to change it into U's. So that's what U substitution is. And we're going to use that idea to help us solve these last three problems. So find the exact value. Please make sure you know that that means no decimals are allowed. And here's what you're going to do. As always, with function composition, you're going to work from the inside out. So you're going to look at the arc cosine of 2/3. Then you're going to look at this cosine. This is a positive cosine. According to the arc cosine rules, you can only be in quadrants 1 or 2. And if you have a positive cosine, it means it has to be quadrant 1. Here's where the U substitution comes in. You're going to let U equal whatever the inside thing is. How do you get rid of an arc cosine? You take a cosine. So if you take the cosine of the left side, you get the cosine of U. If you take the cosine of an arc cosine, it switches to just be 2/3. So here's why we wanted to do our U substitution. We now have the cosine of U equals 2/3. And we have to be in quadrant 1. So you're going to draw a triangle in quadrant 1. This is U. A cosine is an adjacent over a hypotenuse. You're going to find the third side by doing the Pythagorean theorem, and that's going to give you the square root of 5. Because you made this inside equal to U, what you're actually being asked to find is the tangent of U. So the tangent of U is the opposite over the adjacent, which means your final answer is radical 5/2. I think you probably will like these better because they're more familiar, but certainly you'd have to tell me. And you're going to do a similar set of steps no matter what the question is. So here in number 13, look at the inside. Or we'll look at the inside here. So this is the arc sine of -3/5. If you look at the inside here and you see that it's a negative sign, remember that the range is only from -pi/2 to pi/2. So if you have a negative sign, you actually have to be in quadrant 4. You're going to let U be equal to whatever the yellow is. How do you get rid of an arc sign? You take the sine of both sides. So the sine of U equals -3/5. You're going to draw a triangle in quadrant 4. Here's your U. A sine is an opposite over a hypotenuse. This is a 3, 4, 5 triangle, so this is 4. Because of the fact that you let U be equal to this entire thing, what you're really finding is the cosine of U, and the cosine of U is the adjacent over the hypotenuse. And there's no other way to do this. The calculator will not work. The calculator will only work if this was the cosine of an arc cosine or a tangent of an arc tangent. It doesn't work if you have mismatched functions. Questions before I show you the last one? Okay, so the last one just has extra variables. So starting again, as always, with the inside. Just so you know, this restriction here, you're going to need it for the answer. So it doesn't really mean much other than it's a qualifier that has to be there. But work from the inside out. Taking a look at the fact that you have a positive cosine. A positive cosine means you're going to be in quadrant 1. You're going to let U be equal to whatever the yellow is. To get rid of an arc cosine, you're going to take the cosine of both sides. Oops, sorry, I lost my 3. You're going to remind yourself that 3x is really 3x over 1. So you're going to draw a triangle in quadrant 1. Here's your U. A cosine is an adjacent over a hypotenuse. You have to find the third side. So if I just call the third side y, Pythagorean theorem says 3x squared plus y squared would be equal to 1 squared, which means that 9x squared plus y squared is equal to 1, which means that y squared is equal to 1 minus 9x squared, which means to get the value of the side, you would take the square root. Normally, whenever you take a square root, it's plus or minus. Because you're in quadrant 1, it's going to be the positive. And do not actually try to take the square root of this. You do not know the square root of this. It's not 1 plus 3x. It's not 1 minus 3x. You do not know it. So you're going to leave this third side as the square root of 1 minus 9x squared. And then the final step, so because you made this your U, what you're really answering here is the sine of U. The sine of U is the opposite over the hypotenuse, which is the square root of 1 minus 9x squared over 1. And you could put the 1 or not put the 1. It's up to you. And then just FYI, that's why you needed this x thing. Because if you had anything bigger than a third or less than 0, you would get an imaginary, which is not possible. So it's just a qualifier that has to be there. So not an easy lesson by any stretch of the imagination. There's obviously a lot going on here, which is kind of why I wanted to do the review yesterday, to kind of put a pin in all that graphing stuff to make sure that you could hopefully spend some time this weekend focusing on this inverse stuff. So here is homework number 53. If you want to go ahead and write it down, it's a book homework. For this first section here, these are just all the types of problems asking you for arc sines and arc cosines. You just have to make sure that you are using the correct domain. And then everything else you're going to do one at a time.